Alright, let's look at the differential equation of the quantity 1 divided by 1 plus y squared plus cosine x minus 2xy all times y prime equals y times y plus sine x. And this is also an initial value problem where y, when I plug in 0 for x, I will get 1. Now, this differential equation we're going to use the exact method on. So the first thing I'm going to do is I'm going to turn that y prime into dy over dx and multiply that dx over to the right side. So I have 1 over 1 plus y squared plus cosine x minus 2xy times dy equals y times y plus sine x dx. Now, in order to use the exact method, I need to have this equation equal to 0. So I'm going to subtract that right side over, and I have negative y times y plus sine x dx plus 1 over 1 plus y squared plus cosine x minus 2xy dy. And this is all dx. Now from here, I'm going to distribute that y on the left side, so I get negative y squared minus y sine x dx plus, and it'll stay the same thing for the second term, so 1 over 1 plus y squared plus cosine x minus 2xy dy equals 0. So from here, I need to verify that I can use the exact method. And with that, I'm going to take my m term, which is this first term, and do the derivative in regards to y. And then I'm going to do the second term, which is my n term, and do the derivative with respect to x. So for my, I will get negative 2y minus sine x, because that is my derivative of this portion in respect to y, and my nx is negative sine x minus 2y. So I know that these two are equal, so I can check mark that off and verify that it is exact, and I can continue on using this method. So now my m is that first term, which is negative y squared minus y sine x. And my n is that second term, which is 1 over 1 plus y squared plus cosine x minus 2xy. Now my next step in this is I'm going to use the equation f of x comma y is equal to f tilde x comma y plus g of y. Now in this situation, I need to figure out what my f tilde is, and that is my integral of m. So f tilde x comma y is equal to the integral of m dx. So I have negative y squared, since there's no x's, I just have the integral of dx, minus, pull out that y from this second term, so minus y times the integral of sine x dx. When I do this integration, I get negative y squared x plus, because my integral of sine x is cosine x, and I have a negative here, so plus y cosine x. So like I said, this is my f tilde, and I'm trying to solve for f x comma y. So I'm going to set that equal to, I'm going to substitute this f tilde x of y into this equation. So I have negative y squared x plus y cosine x plus, and then I'm going to add this g of y in there. So plus g of y. From here, so this is my f of x comma y. From here, I'm going to take the derivative of this equation with regard to y. So I get negative 2yx plus cosine x plus g prime of y. Now I'm going to set this equal to my n, which we found to be 1 over 1 plus y squared plus cosine x minus 2xy. So that's going to be on my left side of this equation right here. So 1 over 1 plus y squared plus cosine x minus 2xy. From here, I'm going to simplify both sides of these equations, so I see that these two terms will cancel when I add one to the other side, and when I subtract one of my cosines, those will cancel. So I'm left with 1 over 1 plus y squared equals g prime of y. From here, I'm going to take the integral of both sides. So my integral of that left side is one of the integral formulas, so I get tangent, or the inverse tangent of y, and my integral of g prime of y is g of y. So from here, I can plug my g of y, what I just found, back into this f of x equation. So I know that my y tilde, which we found here, which was my negative y squared x plus y cosine x, so I'm going to have f of x, or I'm going to set it equal to c. So I have negative y squared x plus y cosine x plus inverse tangent of y is equal to c. Now, they told me that this was, they gave me an initial value for this problem. So they told me that it was y, when I plug in for 0 for x, I should get 1. So we need to finish this equation and solve for c, because right now we just have it as an arbitrary constant and we need to find the unique solution. So we need to plug in 0 for y, or 0 for x and 1 for y. So we get negative 1 squared times 0 plus 1 cosine 0 plus tangent of 1 equals c. Now when I simplify this, my cosine at 0 is 1, so 1 times 1 is 1. My first term is 0, so that just cancels out. Plus, and my inverse tangent at 1 is pi over 4. So 1 plus pi over 4 equals c. So now that I found my c, I can plug this back in to this equation and have a constant for my c. So I have negative y squared x plus y cosine x plus the inverse tangent of y is equal, and then plugging in my c, 1 plus pi over 4. And that is how you solve this differential equation using the exact method.